Picking up with this will be the second video. Again, you can set up the H-bridge chip and then drive it the input signal with a function generator and see what period seems to or frequency seems to make the motor run the best. And then, of course, what you're going to write a program using analog write to drive that motor. Now, so you can use the analog write, which doesn't actually write an analog signal, right? It creates a PWM signal, and the PWM signal is on most of the pins. You can use it with on the Mega with pins 4 through 13. Is around 490 hertz, but there's a couple of pins you can check that out that are actually 980. So if the motor, if you in this part right here with a function generator, if you found that the motor ran really well at a certain frequency, then you might pick the pin that has for the analog write that has the frequency closest to it. So you might pick 490 or 980 depending on which one the motor runs better at. The other thing you have to be careful of is when, in terms of this chip, there's the power that powers the chip, and then there's a power that powers the motor. You want to make sure that the power is turned on, so your Arduino is turned on, and along with the battery is plugged in and turned on as well, to drive to get that regulated 5 volts to drive the chip before you turn on the power supply with the 12 volts. So if you don't do that, if you turn on the power to the motor that's going to be used to drive the motor to the 12 volt power supply, then you could end up damaging the chip. Okay, so again, on the Arduino, you generally for inputs you use pull-ups, and as I mentioned before, for the chip, the H drive chip, you're going to actually pull that down at the inputs. And there's some questions here that you can look at. So yeah, and we just talked about the importance of powering up the Arduino first before you connect the motor power supply. Next, we want to talk about this simulation. So if you, let's see, oops. Okay, so for the simulator, if you unzip the zip folder there, the MATLAB 2001 Lab 4 simulator, and you can see there's some a bunch of MATLAB files here. There's also an instructional file right here that explains how to unzip the file and then basically open all the MATLAB files, and then you're going to run this working PID, which has 2 arguments, the angle in radians and the mass in grams. And then you can play around with tuning it, setting K sub P, K sub I, and K sub D, and then resaving it and running it again. You don't have to change the length of the arm, and the stand is already set, so you don't have to change that. So let's look at that for a second. So what I'm saying is you can just pick all these and then unselect that one and then select open and just wait for MATLAB to open them. So there's several different MATLAB files here, and I've already asked you to learn or to try to become pretty good with SolidWorks and MathCAD. So MATLAB is a good program to learn, but this program is already set up. So if I click on working _ PD, you can see these links right here you don't have to bother with. Here's the K sub P, K sub I, and K sub D. And the function that this is will be looking for is the angle and the mass. So let's see if I can run this. So what this is doing right now is this was set to 45 degrees, and I'm going to have to pick up from here with the next video.